So the event today is consisting of a talk from Ariana Mansfield from Tech Systems, so she's going to open this up. The first panel is on smart building or construction technology. We have some very exciting entrepreneurs here that are influential in really, I think, something that's happening in other parts of the world but hasn't been prevalent in Boston. So that's modular assembly, as well as some other technological advancements that really help to accelerate the pace of a construction project being finished, almost cut the time in half. So for the developers out there, there's nothing that they like more than getting to that finished product so they can, get the stability. The second panel will be on will be on smart buildings. So smart buildings is the phenomenon of controlling systems from a Bluetooth tethered smart device. And so there's a whole series of networks that can now be controlled from one central panel. And learning about buildings from Nerva, the CIO from CBT, and some of the information you can get from a building from an operational standpoint and the benefits of it, we're going to hear from some of the top companies in the marketplace, Train, Schneider, Tech Systems, Centria, and Suffolk Construction. So with that, I'd like to introduce Ariana Mansfield to give an introduction to the market and smart buildings.
Hello everyone, my name is Ariana Mansfield. I'm the Regional General Manager for the New England branch of Tech Systems. We are a building automation system and building technology integration contractor. I moved up here about 2 years ago to expand the company from New York City into Boston, and we're about 140 people in New York, and we have a much smaller operation here, but we're growing very rapidly. I'm a professional engineer by trade. I've been in the industry for about 10 years, and I'm here to talk to you a little bit about smart building infrastructure. When most people think about smart buildings, they think about the Internet of Things, they think about the cloud, they think about data analytics, but what most people don't think about is the actual infrastructure that needs to go in to support these technologies. The way that networks are installed today is you have many different systems contractors that operate in a vacuum. You have your building automation system contractor, you have your lighting control contractor, your Wi-Fi, your security, your voice over IP, your elevator control system contractor. There's many different technology contractors that are hired by a general contractor, and they all operate on their own. They all have to engineer their own network. They all have to hire their own electrical subcontractor to install that network. They all have their own network gear, and they all need space in the building in order to put this network infrastructure in. It's a large coordination effort in the field, which I'm not sure how many field people are here, but it's usually pretty chaotic, and these trades are coming in at the end of construction, which is the most chaotic part, and you have a pretty large effort from the general contractor. The concept of a converged network is to put a single network infrastructure in to support all of the building systems, the building IP systems. It acts as a superhighway where each system pretty much gets its own lane. So you have a highway that has a bike lane, it has a car lane, you have a walking lane. Each system can ride on the network without interfering with each other. And the network consists of fiber optic cable. Fiber optic cable is the size of a human hair. It's made of glass fibers, and the glass fiber is encapsulated with another piece of glass. It transmits communication signals with little pulses of light. We're used to category cable, which is copper, that transmits communication signals through electricity. The glass sheath around the little fiber, it makes sure that the light doesn't, it reflects the light into the fiber cable so that it can transmit the signals without any interference. The capabilities and bandwidth of fiber optic cable are, as we know it, pretty much limitless. We're only limited by the electronics on either end of the fiber. As we grow and as we become more advanced and we switch out the end devices with more advanced technology, the fiber has been able to support all of this. There's also no maximum length of cable pull for fiber. With category cable, you're limited to 330 feet of communication cable. So as our buildings get taller, as our buildings get longer, you have to segment the network, which requires more network gear. The network gear requires space, electricity. It's costly. So converged networks, why would you put a converged network in your building? Putting a converged network in your building moves the technology trades the buyout to the beginning of the construction process. You get your technology trades on board early enough to be involved in the design of the converged network. Usually these trades come at the end of the construction process when the building's already designed. They don't really have a lot of input into what goes into the building. So there, issues pop up later on that need to be fixed with the design. If they were brought on earlier, they can get involved with the design development. There will be one system integration contractor that will bring everyone into the room and get everyone talking early on, so nobody's living in their own little vacuum anymore. When systems need to be integrated with each other, we're not waiting for the day before the building's supposed to be open to figure out how the lighting system's supposed to talk with the building automation system. It's all worked out early on. You have a lower installation and maintenance cost. We estimate that putting a converged network in will cost about 50% less than the aggregate cost of all of the disparate networks going in. Maintenance cost is also reduced because you have one company that's going to manage your network. That management company, if you choose to hire a third-party management company, can do 24/7 monitoring of your network. So if there's any system faults, they're going to know about it before you do, and they can dispatch service personnel. Since you're saving money on your install and ops costs, you can invest in some more sophisticated network gear. With that sophisticated network gear, it can bring you a higher level of security. Security is obviously important to owners and developers, but really it's not talked about that much with the individual technology trades. As a building automation system contractor, I'm rarely asked what security measures we're taking in order to make sure that our network is secure. So if you have one network and somebody is managing that network and is really focused on security, you can have a pretty secure network. You can have a more robust firewall. You can have an authentication process when somebody needs to access the network. You could also have port management. So if one port is assigned to talk to a security camera, if that security camera is disconnected and a different device is connected to the network, that port will be disabled. So people coming in trying to connect to the network with their laptop, that's not going to work out for them. Also, a converged network is going to require less space. Instead of having multiple different risers going up your building, you're now consolidating that to one. So you no longer need larger shafts for everyone's risers. You don't need as much space in the IT closets because you're reducing the number of switches and network gear that goes in there. So that leads to more rentable space for the owner. It also reduces the amount of cooling capacity required for those IT closets, and it also reduces the amount of electrical load that you have. And then why everyone's here, to hear about smart buildings. This is the infrastructure that's going to be able to support your smart building and the future of smart buildings. As we said before, the fiber optic cable, the speed, the bandwidth of the cable is what you need in order to support the amount of technology that's coming with the Internet of Things devices. It's also expandable, and it allows you to future-proof your building because of the capabilities of the fiber cable. Once the fiber cable is in your building, you can change out the end devices to more sophisticated devices. The cost of fiber is also relatively inexpensive. So to purchase a 10 fiber bundle versus a 150 fiber bundle the cost is relatively negligible. And if you're already having someone pull that network up the building, your increase in cost is not going to be significant, and you have additional capacity in your system to expand in the future. So that's another, you can use that also if you're a tenant-driven owner, you can sell that to your tenants. If you don't have your tenants on board when the network is being designed, when the building is constructed and they sign on afterwards, you can say, we have the capacity for you to connect whatever smart devices and whatever systems you feel like you want to have in your space. So we feel this is the best investment if you intend to have a smart building, if you intend to expand the technology in your building as it becomes more readily available to you. This is the way that the industry is moving. So, any questions?
I may have missed the beginning, but are you guys just a designer? Are you a supplier? What do you guys do?
So we will help with the design of the converged network, and we will also install it. We install it. We're usually hired to install the distributed antenna system, the cellular DAS, and then we pull this with that. But we can just be a converged network contractor.
Are you union?
We hire union sub-labor, yeah.
So this is new technology to the city of Boston, Ariana. Have you installed any to date in the city, or do you have any plans to?
So there are no buildings that I know of in Boston that are currently constructed with this type of network. We are in talks with one of the major developers in the city about a tower that's going up within the next couple of years. We have installed converged networks in several buildings in New York City. It's gained popularity over the past 2 years in New York City. It came from overseas in China and Dubai, slowly made its way over to the United States, and we're doing it in some 70-story towers in New York City. Hudson Yards, Manhattan West are some of the few that are going in currently.
Are you seeing a requirement for the gas systems to be protected in a fire-rated enclosure?
I'm sorry?
Are you seeing a requirement for the DAS systems to be within a fire-rated enclosure?
I have not heard that. I can get back to you if the rest of my team has heard of that requirement. But I don't, the ones that we're installing in Manhattan, I don't believe that that's a requirement. Yes.
Yeah, no, I'm just wondering, what is it you think it is about the offshore countries that has allowed them to move this technology much faster than the United States?
So what I've seen with talking about this with people, so when I first moved up here 2 years ago, we started as a building automation system contractor. So came up here, started talking about building automation systems, talking about converged networks. I got cross-eyed looks from people. I don't even want to talk to you about that. I don't know what it is. People are scared of the unknown, and a lot of developers see this as risky. I've had questions asked about what happens if the entire fiber backbone is cut. There are many different redundancy tactics that you can put in. The networks aren't often just completely severed, but I understand the challenges that developers see with adopting new technology. But it's risk taking on the developer side to want to put this in. You have?
Yeah, you guys just haven't gone over any of the, like, kind of how it connects to carriers and, like, who maintains these lines and how actually, like, people would connect to this to be able to bring it in with the different pathways.
Yeah, so this would be a typical IDF closet. So you have the fiber backbone that originates in an MDF room or a meet me room. They're not actually on the ground floor anymore in the basement because of flooding. They're starting to move those up the building. But all of the carriers and any outside services come into the building, into the MDF room. From there, it distributes up the building to IDF rooms, where you would see something like this. These are all managed switches. Each port is assigned to a different contractor. So the building automation system contractor needs 3 ports on the 4th floor. Okay, so we pull enough fiber up the cable for those 3 ports. There's 10 security cameras, each security camera needs its own port. So you pull 10 fibers up the building from the MDF room to the switch to accommodate for those ports. And then the technology integrator who manages the whole process and manages the switches will open those ports with assigned IP addresses to those specific devices. And then it's the same infrastructure, they're riding on the same fiber backbone, but through IP addressing and through the managed switches, they won't interfere with each other or talk to each other unless they're intended to talk to each other. That answer your question? And then as far as management, there are a bunch of different options. The building manager can take it on themselves. They can hire their own IT people. There's third-party management. We can help with that. There's a bunch of different options. It kind of just depends on what you want to do with it.
Are the buildings typically not relying on the carriers to manage this fiber then? Is it something that the ownership of the building is subcontracting, so the fibers essentially are not owned by any of the carriers?
No, it's owned by the building, yeah. So you're referring to DAS, right? To distributed antennas. So by carriers, or you mean like Verizon and yeah. So this is so that's the distributed antenna system, where you're extending the macro cell of the carriers outside your building into the building. So this is so the distributed antenna system's backbone is pulled alongside the rest of the converged network, and that's separate. So it's owned by sorry.
No, you're talking about like cell phone antennas?
Yeah.
No, we're talking about, we're from Comcast, so we're actually
okay.
but that actually, we do a lot of cell backhaul, so
Yeah.
that's very relevant to us, but we're
Yeah.
actually looking more to understand like how you would connect, a cable provider.
Yeah. Okay. It's a similar process, and it is owned by the building. But we can chat more about it after.
So we'll have a panel, there'll be some more questions that can be asked. So I just want to move to the first panel. And I just want to introduce, thanks.